talked last time about whether this matrix and that matrix were inverses, right?
That's right.
Right. This time,
We're not.
we're going to talk about how to find the inverse of a matrix.
Oh no. Okay, I'm sad for it. Probably need my whiteout discussion.
When I get like
It's the rest of lesson 8.
Mine's purple.
Okay, so if A is the matrix A, B, C, D, then the inverse of A is 1 over the determinant of A, but we'll write it full out. A times D minus C times B. Right, because that would be the determinant, yes. Times the matrix.
I watched a video on this yesterday.
Did you really?
Yes.
Nice. D, negative B, or the opposite of B, the opposite of C, A. So we take and we switch these twos, this diagonal, and this one we do the opposite of.
Is this a continuation of that lesson?
Yes.
I don't know how they figured this out.
Wait, lesson 8.
I'm sure there's a proof out there.
Yeah.
And for this to be true, there is a condition. So where? No, not wow. Where? Where the determinant A times D minus C times B is not 0.
Oh wow. Okay.
What if it is 0?
It doesn't have an inverse.
Wait, so that's like a.
What?
I was gonna like label what that was. But.
This is all. This right here would be the inverse of a 2x2 matrix. That's a condition. Condition is the word you're looking for. So let's look at an example. Example. I don't know. No. Example 1 is how we're doing it. Yes. Matrix P is 7. What am I writing? I'm struggling with writing today. Don't know why, but I am. Negative 5. Hey, we still have class. You just have to do it at home. Unless I was like very ill or something.
Do not become very ill.
That's the plan. Okay, so the first thing we need to do this is to find the determinant of P. Right?
I just like math, but not that much.
We do?
I'm not determined.
Yes, because this is the determinant of the matrix. Right?
Bless you.
Oh no, the floor has COVID. No, just kidding.
Yes, it does.
All right. So that would be 7 times negative 1 minus 2 times negative 5. Right? So that would be negative 7 plus 10. So that would be 3. Correct. Why?
Wait, why did you
because I'm not there yet. That's just the determinant of P. So now our next step would be to do one. So for the inverse of P, it'd be 1 over the determinant, which is 3, times the matrix -1, 5, -2, 7. Right? Did we follow where those came from?
Yes, I do. And what will
Wouldn't it be
the
negative? Wouldn't it be positive 2 and negative 5?
Nope.
It's
Because they were -5 and +2.
It is -2 and +5.
So we just switched it off.
On the thing.
No, why did you switch -1 and 7?
Because
So
they
it's
swap.
flipped.
So that's how that works. So this is our definition. These two, maybe I should leave that on there.
Oh, those two switch, and then those
Yes.
two just.
These two switch position, and these ones end up opposite.
Oh, okay. I get
So
it.
if it's a negative and it's positive.
Okay. So now.
Donde está?
Dos bibliotecas.
Downtown.
I love that word because it sounds like a bad word.
It does.
Pencil sharpener.
It does. It's a library, right?
No, pencil sharpener.
Bibliotecas.
Oh, that.
What?
Sacapuntas.
I
Sounds
don't
like
know.
a bad word. It's just pencil sharpener.
Sharpen your pencil.
I mean, pencils are sharp, so that's
There was one
dangerous.
guy who was jumping over. He was a little kid. He was jumping over a pencil, and it was like stuck in his ground. He was like 5,
Right there.
and he was like sticking up like this on the concrete, and he was bored, so he was just ding, and he was barefoot anyway.
So dumb.
I know, right?
Have you ever stepped on a nail?
Or
Yeah,
like,
I stepped
oh,
on
A nail this long went through my foot when I was like 11.
I had a piece of glass this deep in my foot.
oh.
Oof. Mom always took the tweezers and I was like, I can't see the tweezers anymore. I don't like that.
Oh no.
Yeah, I just stepped on it and then I lifted my foot and it came out because it was in a board. And you just like feel it coming out of your foot.
Oh.
It was interesting.
Was it rusty?
Yes.
Ugh.
It was.
Yeah. That's all. I've gotten gone through my shoe and like
Yeah.
almost into my foot.
What's that for? Is that
Kleenex. So I don't have to walk around all the time. I can just stand here.
Is that
Oh, I can't
barf bucket or something?
It's my barf bucket. Yes. Hopefully I don't need a barf bucket, but you know. Okay. All right. So do we understand where these came from now?
This
Yeah.
recording's gonna be
Yes.
Okay. So, how do we multiply a scalar times a matrix?
Like that.
Distribute UT.
Essentially, we're going to multiply this times this one and that one and this one and that one, right?
Distribute
Okay, so what is 1/3 times -1?
-1/3.
Whoa!
Wow.
Wow!
Wow.
What is 1/3 times 5? Put your calculator away. You don't even need it. What's 1/3 times 5? Yes, you can. What's 1/3 times 5?
Put it over 1 and then 1.
5/3.
There we go.
Great job, guys.
I knew that.
Yes, you did. So what's -2 times 1/3?
-2/3.
-2/3. What's excuse me? 1/3 times 7? 7/3. It is super easy.
Well, you can smart.
You can smart it down.
So,
Sorry.
this is the last time. We won't always do this, but how could we check to see if we did this right?
You don't. But they all have threes and one.
Didn't we learn last time to see how to figure out if things are are inverses? So how would we figure out if this one and that one are inverses? Multiply them together. True facts.
What does that negative 1 on the P do?
That means inverse.
So we don't do anything with that?
That means inverse. That's all it means. It's just a notation thing. So there's nothing to do with it. It's a good question. So let's multiply it real quick. We'll only do it one way. So we won't fully prove it. But so our original P, so we're going to do P times, hopefully, the inverse of P, right? And that should equal this matrix, right?
Sure.
So P was 7, -5, 2, -1, right? Is that right? Did I do that right? Did I brain correct? Good. Times the one we just found, -1/3, 5/3, -2/3, 7/3. So to multiply those two together, what do we end up with?
7. We end up with 7 times -1/3.
7 times -1/3.
And -5 times -2/3.
And then, what do you mean and then? What do I put here?
Plus.
Okay.
Yeah, plus that one.
Plus -5 times -2/3. And then
Blank. And then you do 7 times 5 over 3.
7 times 5/3 plus
-5.
5 times 7/3.
And then do the same thing on the bottom.
Yay. 2 times -1/3 plus -1
-2/3.
and -2/3. And then 2 times 5/3 plus -1 times 7/3.
Look at the second number and flip them. They just put all.
True facts.
And then the other ones just switch.
So this ends up being -7/3 plus 10/3. This one ends up being, what is that, 35/3 minus 35/3.
Look at that.
What? This one's going to be -2/3 plus 2/3.
Oh, look at that. It's going to be 0.
And then 10/3 minus 7/3.
Wow, look at that. It's the same.
So it works out as 1001. So, yay. Now, technically, we're not done if we're checking inverses, right? We have to go the other way around. But we're going to make an assumption at this point that we're happy. We proved it works. Yay.
Yeah.
Sound good?
Yeah.
All right. So, what?
I'm not sure what that one is.
I do those kind of things all the time, but you can tell it more on our virtual live streams because my little man goes in the thing. By my little man, I mean the virtual me. Okay, now. Okay. Okay. Normally in class you can't see it. And the people whoever watches this video, whether it's you people or some other people who stumble upon these videos,
You're gonna be a little weirded out.
they never know. They don't know that I have a little dance. Okay.
I feel like
Y'all don't know most of the time either because you're going.
Yeah.
Okay.
I feel like at the start of each video we should all introduce ourselves for any random person who comes by.
You could do that if you chose to. That would be your deal.
Next time we do
Example number 2. I want y'all to do this one. Ready? I want you to find the inverse of Q. So Q is the matrix 3, 7, 1, -4. I'm going to pause the recording. If you are watching this at home, you should also pause the recording and do it on your own.
See ya.
Welcome back, humans. Does it sound like I'm an extraterrestrial? That is what we should have done and should have gotten. Questions on that problem?
Not done with it, so
Why not?
I did not get that.
Why not?
I think I didn't do correct things with my negatives. So yeah, my
Okay.
negatives are a little off. I was supposed to subtract it, not do it differently. Oh, that is negative. That is my problem.
That makes sense.
So now it's
How do you know which numbers to make negative when you're
so it's 19 instead of 5.
What are you asking?
the inverse of negatives or
So right here.
Yeah.
So remember the down diagonal, we just switch places. We don't change the sign. Right? This one and this one, we leave them in the same place and we do the opposite sign. Should be right there in black and white, assuming you're writing in black.
Or white on white paper.
Could be a thing.
That's a thing.
I said it could be a thing.
There's like could be a thing. This would be a good idea, but
Instead of black and white, that would be white.
It's not even cold. Y'all are lying.
our zebra is white stripes.
Okay. Any other questions on this problem?
Their skin.
Normally it would be wise, but we're not going to do that right now. Okay, so let's do number 3. I want y'all to do this one on your own too. You're going to like this one, assuming you think through it correctly.
Upside down.
So A equals -8, -6, 12, 9. Ready, go.
What?
You need to go watch the video on integer rules, man. I'm telling you. So that is what we should have gotten. The inverse of A does not exist.
So wait. Okay. Oh, I thought that's a 1. Wait, how does it 1? D and E
Does not exist.
Okay, I thought it said 1. It's 0. For a second, I was done.
No solution.
False. Different words. Means something technically different. I probably wouldn't count it off, but
Technically a solution.
okay. What?
A non-solution solution. D and E.
There's a solution, but the solution is that it doesn't exist.
Wait,
Okay.
3 dots and triangles therefore.
It is therefore.
Oh, I thought it was a trifle issue.
What is therefore? Therefore. Okay.
Oh yeah, that makes sense.
Yep.
Or 20 today.
Good way to analyze scripture. When there's a therefore, you got to go back up and read and figure out what the therefore is there for. True facts. Okay.
You want a chapter. Therefore. Like, no.
No, can't do it. Now I got to go back and figure out what I'm doing.
It's a large portion of my phone.
Okay, so that is how to find the inverse of a matrix. Now we're going to talk about how to use all of this information to solve a system. Yay. Okay, so first of all, we're going to look at how to find a matrix equation of a system.
Is this one your last one?
No.
Is there a continuation of the
I don't know who you're talking to. He's a teacher. How would I know who you're talking to? My name is Mr. Fulkerson, or Sean in this class, apparently.
Mr. Teacher Fulkerson.
My old students would be like, "What? You let them call you?" Yes.
I don't think I've ever called it the same shit as actually no normal name. You have the same.
That's lies.
No,
But it's similar.
no, this is not true.
Matrix equation of a system. Okay. We're going to illustrate it with an example. Okay?
This is gonna be a lot.
No. Okay. So if I have the matrix X plus 2y equals, mine is darker, and I pull it off better. Okay. Equals 9, 3x minus 6y equals 3. Okay. The matrix equation of this would be this. You ready? Pay close attention. 1, 2, 3, negative 6 times the matrix, the column matrix xy equals the column matrix 9, 3. Questions? Understand? Does that make sense? Am I recording? Yes, probably yes. Yay, verily, yay. Probably the best Danny Kaye movie ever made, except maybe White Christmas, maybe. Court Jester. Quite good. You don't like White Christmas? What is wrong with you?
Song's amazing.
No, it's not. It's not at all boring. It's hilarious and it's fun and it's great. You're boring. Okay. Wow. Here's a bit of trivia for you. You know the song White Christmas? It originally came from a movie. That's where it came from a movie. Do you know what movie it was? It was not White Christmas. That is the misleading idea, but it did not come from the movie White Christmas. No. It came from Holiday Inn.
Oh, that's right. I knew that. Oh, good. I knew that.
Yes, it did. Yes, it did. Which is also a great movie.
That one's
I still consider it. That one is the one you think is fun. I do like Holiday Inn. I like it quite. I admit it's great. But you like that movie, and then you say White Christmas is boring. I'm confused about your life. Okay, but it's okay. That's okay because usually he's confusing me, so we may as well spread it around the room. So it's fine. All right.
I make the most sense of anybody in this class. No.
That made no sense.
Besides me.
Y'all just don't make the same level of sense. So I seem.
Okay, so we're gonna do kind of this is kind of a proof. Are we good? This is kind of a proof, sort of. Are you paying close attention? So this, if we call this matrix A, and we call this matrix X, and we call this matrix B, what?
Why not Y?
Because I said so.
So it can be Y?
Okay. Then if we were to rewrite this, this would be A times X equals B. How do we get rid of something on one side of an equation? We do the inverse. Really is what we're really doing. Like if our equation was 3 times x equals 7, we would use the multiplicative inverse here, right? The multiplicative inverse is 1/3, right? If it was x plus 2 equals 8, we would use the additive inverse. So minus 2, right? So we use the inverse, right? So that's how we get rid of it. So we do the same thing up here. We can multiply both sides times the inverse of A. To get rid of that. Because then these two would cancel. This is going to make more sense when we put real numbers on it. Okay. So x equals b times the inverse of A.
So we just do what we did for 1, 2, and never even.
What?
We basically do these sorts of problems for A.
What we're ultimately trying to find is this matrix. Is going to be our answers. Let's do an example with numbers in it so it can make better sense. How does that sound? Y'all great?
I am like dying.
You're dying?
I'm dying.
Everybody is dying slowly. Some of us faster than others. But everybody is dying. I mean, that's like from a Judeo-Christian standpoint, we're dying because of the fall. True facts. Now, moving on. Moving on from scientifically, we're dying because of entropy. Sort of.
Basically both.
Okay. Let's do an example. Solve using inverse matrices. Beautiful? Beautiful. The matrix we're going to use is, the system we're going to use is x plus y equals 24.2.
What about that other one, the x plus 2y?
What you talking about, girl?
The one has been solved.
We certainly could do it in a minute. That gonna give you a sense of completion up there?
Wait, why did you put x? Oh, okay.
5x plus 3.5y equals 88.05. So that's the matrix we're going to solve. Making sense? Say yes. We haven't done anything yet. How can it not make sense? All we did was write down the problem. You don't know how to read? This is the wrong class. Okay. What? Are you being a hater right now? Okay. So, first thing we're going to do is we're going to set up our matrix equation for this system. So, what would the matrix equation for this system be? What would the first one be? How about 1, 3.75, 3.5, yes. From right here and right here. Yep. Good. Times xy equals 24.2. 88.05. So, in order to use this formula that we derived right here, we got to find the inverse of this one, right? Yes. Okay, so we need to find A inverse. So the first thing we need to do is find the determinant of A. So what would the determinant of A be? How do we find the determinant of a 2 by 2 matrix? I agree. Yes. Times what? What am I going to put right here? 1. There we go. And then?
Minus 3.75 times 1. Which is
Just the two decimal numbers.
It is not that. You put some weird negative in there. Just put it in exactly as it's written.
Or you just get the 3.5, 3.75 out. That makes sense.
Wait, how'd you get that?
Because 3.5 minus 3.75 is 0.25.
I was like,
Because think about it in like monies.
Yep.
25 cents.
Okay.
1 times.
Well,
So what else do I need to do to find the inverse of A?
Oh, you skipped this one.
yeah.
I hate this.
They're ones. You don't know what 1 times 3.5 is?
325, 1.
Yes, you do. 1 over negative, right? 1 over negative 0.25. Well, before we do, no.
Wow.
Sorry.
well.
Times 3.5 negative 1 negative 3.751. Right? Questions? See or no? Before we do this multiplication, let's clean up this guy. What is 1 divided by a negative 0.25? This is 1/4. 1 divided by 1/4. Which you probably could do in your head, but since we're not used to doing those little maths anymore, because it's not junior high anymore, you might not be able to. What do we end up with? How did you end up here? No, just kidding.
I don't know.
I signed up for the class.
What does this turn into, boyos and girlies?
I don't know.
Well, punch it in your freaking calculator then.
Wait, what part?
It's actually pretty easy to do in your head, but if you can't, then do it in the calculator. 1 divided by negative 0.25.
Whoa, -4.
It is -4.
Wow, that's -4.
Because 1 divided by negative 1/4 is 1 times the reciprocal of that, which is -4 over 1. So -4 is the answer.
Wow.
Yeah.
Don't worry about it. Just punch it on your calculator.
That's cool.
Did you get -4 when you punched it? Yes, probably. Still doing it?
84.
I got 0.14.
You punched this and you got 0.14?
I got 0.
Just 1 divided by is all you're doing. 1 divided by negative 0.25.
Yeah, I got 4.
Good.
This should be -4 or not?
Yes, it should be -4. Okay. So when you multiply that -4 in there, what do we get?
12. So there's no 1 above it anymore?
No.
No, because we simplified this mess.
Negative 14. Positive 4.
Three and 3/4 would be 4, 12, 15. Sorry, I was trying to do it in my head. Be 15. It'd be 15 fourths. So 50, is it 15? Positive 15? Is that what you got?
Yes.
Yeah, for the second one. And then this would be negative 4. So that I don't know why I decided to have a lisp all of a sudden, but it happened. So the inverse, what did you get, sir?
Wait.
What are you saying, Daniel?
I'm saying I'm not.
Oh, good. So there's the inverse of A. So going back to our equation, all we have to do is multiply that times B. And B is this guy over here on the other side, right?
Oh, that one.
That one.
Oh,
So we got to multiply B times this to do our last bit. So B in our problem was, it's not going to be long enough, 24.2, 88.05. And we're multiplying that times the inverse of A. Negative 1, 4, 4, 5, negative 4. Sorry for the ugly handwriting. It just happened. So.
Wait, why is that fun? Why is that?
Because I didn't write a 1. Because obviously I struggled really hard with the 5. So I was just like, forget the 1, right? So to multiply this out, what are we going to do?
No, because there's only 2.
What?
There's only 2.
We do. Did I write it backwards?
Yes, you did.
I did.
Wait, which one?
You did write it down.
I did, because we can't do that. It's 24.2, and what's the other one, y'all?
88.05.
So now what do we do? Yeah, so negative 14 times 24.2 plus 4 times 88.05 is the first part. And the second part would be 15 times 24.2 plus negative 4 times 88.05. Okay, so what do we end up with?
Negative 330.
That's for this or this?
The
First part. Negative, what'd you get, 308?
338.
Point 8.
That's what I got.
Plus 4 times 88.05 is what?
352.
And then 15 times 24.2 is what?
363. Yeah, 363.
Minus 4 times 88.5 is going to be same as what we got there, isn't it? 352.2.
But negative was
True facts. So we end up with this solution. What's negative 338.8 plus 352.2?
13.4.
13.4. And then 363 minus 352.2.
Ten.
10.8.
I was like,
Well, yeah, that's 1008.
It is not 10.08.
it'd be 108. And put the point, yeah.
Somebody said 1008. I would translate to 10.
How we doing? Questions?
So you
Comments? Snide remarks?
Why is it so long?
Because math is dumb.
Yeah.
Sometimes.
Excuse me.
Bless them.
My goodness.
It is really long.
It's extremely long.
Are you excited about it?
No.
Homework. Page 202. Numbers. Or is it Tuesday? Yes. Yes, it is. 18 through 34 evens. Merry Christmas. Questions? Comments? Snide remarks?
How dare you?
How dare he?